Hello everyone and welcome back to Mathematics with Usman. I'm here to give you tips, tools and techniques to take your mathematics to the new level. Today, the topic of our discussion is going to be factors in two dimensions. Students, the syllabus of this particular tutorial is the syllabus of GCSE as well as IGCSE. All quantities that can be measured are called physical quantities, and physical quantities are categorized into scalar quantities and vector quantities. Quantities like length, time, temperature, they need only the number to represent. For example, for the length, we are having the 5 centimeter. 5 is the number, which is the magnitude of it, and centimeter is the unit. No other information is required. Similarly, for the time, we need only the number and its unit. Nothing information is required. In case of the temperature, which is 98 Fahrenheit in this example, 98 is the number, the magnitude of the temperature, and Fahrenheit is the unit of it. However, students, in case of the vectors, the things are a bit different. What else we need in case of vectors, if we define it, is look those physical quantities that have magnitude as well as the directions are called vectors. And a significant thing to learn here is the representation of a vector. A vector is represented by a straight line with an arrowhead. Consider, for example, in the figure, AB is a vector. Its length starting from A ending at B gives you the magnitude. However, the direction is represented in two ways. The first one is the angle that it makes with the horizontal axis, which are the reference axis of this vector. And then another way is to give it a name AB, where it A is its starting point, we call it the start, and B is its ending point and we call it the end. Hence, AB vector represent it is starting from A and ending at B. The physical quantities that needs magnitude as well as direction, for example, can be the velocity of this car or the acceleration of this car. Velocity need direction as well as the magnitude. Similarly, this acceleration, it need the number, it need the magnitude as well as it need the direction, and so does the force applied by the engine of this car. So these are the vector quantities that need magnitude as well as the direction. After the brief introduction to this topic, vectors, let's straight away jump into the objectives that we have to attain in this particular syllabus. So students, there are 6 main objectives that we have to attain. You must know how to calculate the magnitude of the vector. Number 2, represent the magnitude by directed segments. Number 3, you must learn how to add and subtract two vectors or more than two vectors. Number 4, multiply the vector by a scalar number. Number 5, you must know to use the sum and difference of two vectors to express them in a single vector. And the last one, which is the most important one, use position vectors. In this particular tutorial, we are going to discuss the objective number 1, how to calculate the magnitude of the vector, and number 2, how to represent the magnitude by directed segments or how to represent it by the column vectors. Let's dig deep into these objectives, and starting with the magnitude of the vectors. Students, just consider a figure. We are given with the vector A. What you have to do here, you have to take the movement of this vector in x direction as well as in the y direction. If you look at it carefully, students, you will come to know that in the x direction it is moving 1, 2 units, while in the y direction it is moving 1, 2, 3, means in the y direction it is moving 3 units in the positive sense. So we can write the column vector for this particular vector A. What that could be? 2 units in the x direction and 3 units in the y direction. Now for the magnitude, if you see it carefully, this vertical distance here and this horizontal distance here, they form the triangle and A is the hypotenuse. So we can apply the Pythagoras theorem over here, which is going to be the square of the x, the square of the y under the root. So 2 square is 4, 3 square is 9. So the magnitude of the vector A is going to be 13. Let's consider one more example, which is going to be B. If you look at it, how much it is moving in the x direction? 1, 2. How much it is moving in the y direction? 1, 2, 3. So the magnitude of B is also equal to the magnitude of A. That is going to be 13 under the root. Let's take another example of the vector 3. If you look at it, it is moving 1, 2, 3, 4 unit, but in the positive sense in x direction. However, in the negative sense in the y direction, 1 unit. So the column vector for this particular vector 3 is going to be 4 in the x direction and -1 in the y direction. So the column vector is 4 minus 1, and the magnitude of it is going to be 4 square plus minus 1 under the root square, and it is going to be 17 under the root. Let's explore it further with an example. In the diagram, A is the point 60, B is the point 0 minus 4. OACB is a rectangle and N is the midpoint of BC, where CA is equals to AD. Students, we can see that OAC and B, this is a rectangle, and we have to now visualize the properties of a rectangle. And properties of the rectangle says opposite side OA and BC, they must be equal. OB and AC, they must be equal to. Now this point A, it is having the coordinates 60, so it means that OA is moving in x direction only, which is equals to 6. And similarly OB is given, which is 0 minus 4, so this distance from 0 to B is 4. In the first part of the question, what we have to find is express a column vector for CD. Then in the following parts, we have to calculate OC and DO. Now students, just see where the line CD goes from. It starts from C. C is the starting point, means this is the start, and D is the ending point. So we have to calculate the length of this line. We have to calculate actually the column vector for it. So you can see clearly it is moving in y direction only. There is no involvement of x. And we have understood that this point B and ending at C, this line BC and OA, they are parallel. So the distance of if OB is 4, then CA is also 4. And the distance of AD will also be 4, since CA is equals to CD. Hence we can say that the C to D distance is 0 in x direction and 8 in the y direction. So the column vector for CD is going to be 0, 8. Now let's move on to the point OC. If you look at it, this OC is actually the diagonal of the rectangle. Now you can see that OC moves in the x direction as well as in the y direction. How much it is moving in x? It is 6. And how much it is moving in y? 4. But in the negative sense in y direction, however in the positive sense in x direction. So its column vector would be 6 in the positive x and 4 in the negative y. So the column vector is 6 minus 4. Now the last part of the question says DO. A vector DO. It is starting from D and ending at O, which is the opposite of OD. Students, if you look at it carefully, OD, it is the sum of OA and AD. So it means if it moves in the x direction, it is moving 6, in the y direction it is moving 4. And DO is the negative of this vector. So it means that DO is moving 6 in the negative direction and 4 in the negative direction in y place. So the column vector for DO would be -6 and -4. And with that, we end our today's tutorial. I hope it will bring some value to your mathematical concepts. Keep watching Mathematics with Usman. I will see you in another video. Till then, it's goodbye.